In this video, I would like to provide a brief survey of the literature on structural change, sometimes referred to as structural transformation. Now, these terms refer to a process whereby the composition of an economy changes over time along with the process of economic development. The most salient examples of this would be the decline of the share of agriculture, or the increase in the share of services as countries develop. Now, before anything else, I want to observe that for the most part, we are going to be focusing on a closed economy and on an economy where there is no capital. The absence of capital is quite typical in this literature because it makes life easier because you don't have to try and solve the agent's dynamic problem. However, there are certainly papers that do have capital. We'll mention some of them. If we don't have capital, and if we don't have an open economy, it means that the structure of the economy is going to end up being determined entirely by the agent preferences. So now, let's start with one class of effects that might lead there to be structural transformation in an economy. We're going to call them price effects. So first of all, we have to assume that there are many goods. So there's n goods, or goods and services, and let CT be a vector that tells us how much you are consuming of each good at date t. Preferences of these agents will be the usual, where the agents discount the infinite expected sum of utility of the consumption bundle. But of course, as mentioned, the intertemporal part of this isn't very interesting, at least not now. What's going to be interesting is how it is that the agents value the goods relative to each other. And so a typical assumption is that utility is defined over a constant elasticity of substitution aggregate of the goods. So the goods are numbered from 1 to n. So there is going to be some weights. Here is the bundle. And there's going to be a parameter here where epsilon is the elasticity of substitution among the goods. For this to be constant returns to scale, we need the reciprocal of that exponent out here. And finally, we need the sum of these weights to equal 1. So the agent maximizes this each period. So let's write down what they're maximizing, subject to the constraint that their expenditures, so if Pn is the price of good n at this date, then PNCN is their expenditure on that good, we add over all of them, that may not exceed their budget, whatever their budget is, whether it's all their income for this period, or whether it's the income that they allocated towards consumption if this happens to be an environment where there is investment. So let's take the first order condition of this, and what we're going to end up with is that u prime of c times the weight, so this is a first order condition for a particular n, times this whole shebang, where this is to the -1, and of course we have to multiply this out front, And then we have to derive this by one of the ends. I already did that, that's why we have that there. But we also have to take this minus 1 and multiply that out front. And all this is going to equals the Lagrange multiplier on the budget constraint times P sub n. And if we want to be really careful, we want to make sure these things are labeled n prime or something else, because they are not the same n as the one that we're deriving here. It should be very clear that this is going to simplify. These cancel out and become 1, and this is just going to equal minus 1 over epsilon. Since we're talking about structural change, what we'll be doing is comparing what's happening to consumption of one good versus another. So this implies that for any two goods N and M, we're going to get the following. Let's bring this down and divide the expression for N with the corresponding expression for M, a different industry. And of course, you can see this is going to simplify dramatically. The lambdas will cancel here, this will cancel here, this will cancel here, this will cancel, this will cancel, and we'll be left with a much simpler expression. Next, to talk about economic structure, we're going to measure economic structure using the share of expenditure on the different goods. So define S sub n as the share of spending on good n. In other words, S sub n is equal to P sub n times C sub n divided by expenditure B. Then this becomes the following. We'll have S over n divided by S over m, which of course, using this definition, can be written in terms of simply the consumption of the two and their prices. So divide top and bottom by 1 over b, and we get this simpler expression. Now notice that we can bring this down and raise everything to the power of minus epsilon. Then we'll have this to the power of minus epsilon. And this to the minus epsilon, where these exponents here are cleared. Finally, multiplying both sides by these weights, I'm going to end up with this being the ratio of real consumption between these two goods. So I can substitute Cn over Cm with this term here. And what do I get? Well, I can put these together. And I end up with this expression for the shares. So the shares depend on the weights and on the relative prices. Finally, if we're going to talk about structural change, we need to have these shares changing over time. So let's define big G sub n to equal the share at any particular date divided by the share at the previous date and so structural change will mean that G sub n is different for different industries. So once again, we're going to be wanting to compare G of n to a different G of m. So let's compute that. First of all, using the definition, we just have to write those things in here, making sure that we've changed the index from m to n in the bottom. But notice that we can just do the following. Let's make another copy. And notice that this can move up here and this can move down there. So this is simply this equation that we had here, but expressed at different dates. So let's take this and bring it down here. We just need to make sure that this is t plus 1, t plus 1, this one is t, and this one is t. Great. And we can see, of course, that the weights are going to cancel out, and we're going to be left with a fairly straightforward equation here. Let me put brackets around everything. We can take out the power and simplify. So since observe, I can rearrange this one last time. The way we're going to get structural change is as long as the growth rate or growth factor of prices in different industries is different. And then as long as epsilon is not equals to 1, we're going to get structural change. Now epsilon greater than 1 means that goods are substitutes, and epsilon less than 1 means that goods are complements. And so we're getting that if goods are substitutes, then goods that become cheap rapidly grow to dominate. If goods are complements, then it's the opposite. So then the question is, why might it be that prices grow at different rates? And for that, let's look at an example. And this example goes back to Baumol, but it was also looked at again more recently by Naim Pisaridis. Suppose that each industry that makes good N has a production function that looks like the following. So Y sub nt is output of good N at day t, A sub nt is productivity, and let's say L of nt is labor. And to make life simple, let's forget capital. The key is that A and T is some A in 0 times a factor G sub n to the power of T. In other words, productivity growth happens at a constant rate, but this rate is industry specific. So suppose you're a firm that is producing good N. So you maximize your profits, which is revenue or price times output, subject to whatever the wage is, and your choice is L sub nt. Pretty obviously, in equilibrium, you're going to have to satisfy the condition, because this is linear, that the marginal product of labor equals the wage. And since WT is constant across industries, it is also going to be true that this holds for any N, or for that matter for any M. And that gives us this equation, which we can very simply rearrange in the following way. The relative price of good P over good M is the inverse of the relative productivities. So finally, bring this back to the question of structural change. Let's bring down this equation and simplify this first. Notice that we can write this slightly differently. Can move this up, can move this down. Then we can see that this is just that expression. And notice that what's happening with the prices is the inverse of what's happening with the productivities. So I'm just going to write in the productivities here. And remember, we have to invert things, but we can invert things easily by just doing that. So now this is correct. And now one final substitution, again observing that this is the same as this. We can just write G sub N and G sub M. So now we're done. We have shown that if epsilon is greater than 1, so goods are substitutes, then goods that experience faster productivity growth will grow as a share of the economy. If epsilon is less than 1, so the goods are complements, then the opposite will happen, and goods that experience slow productivity growth will expand as a share of the economy. And this, in the two papers mentioned above, is suggested as a possible explanation for the expansion of the service sector as countries grow, if you think that epsilon is less than 1 at the level of broad goods and services. Another example of price effects that doesn't necessarily have to do with productivity growth is Acemoglu and Guerrieri, where the mechanism is also due to productivity growth, but also there are differences in factor shares across industries. So for example, if you are a capital scarce country, the interest rate might be higher, and that makes goods that are capital intensive more expensive. Similarly, Buera, Gaboski, and Rogerson have a paper where it's differences in skill shares that matter, and then structural change depends on the cost of different skills and how that evolves over time. Finally, we have a completely different set of reasons why structural change might occur, and we call that income effects. So to think about income effects, let's go back to our maximization problem here. One way in which you might think there are income effects is because, let's say, there are nutritional requirements for food, and so food below a certain level doesn't give you any pleasure. So one way to do that is to say that instead of depending on your consumption of any particular good, your utility depends on your consumption and a constant. So these are known as Stone-Geary preferences. And so, for example, if we think that N is food, we set C bar sub food to be some negative number. It means that consumption below some value doesn't actually give you any utility. Now what's going to happen when we try and solve this is that, well, we can just bring down our first order condition from before and substitute this in the appropriate places. Right? And then we should sub it in here as well. There. And now, just as before, we can write this for some m and some n separately. Of course, many of these terms will continue to cancel out. This will disappear there. And if we write this out for m, all of this is going to end up going. All of that. All of that. We'll just need to change these to m and m here. The problem now is that if we define our shares as before, you'll notice that S sub n by definition is P sub n, C sub n over B. And observing that I can rearrange this so that C sub n is just S sub n times B over P sub n. I'm going to try and rewrite this, and you'll see very clearly that unlike the case before, there is just not going to be any way in which I can rearrange this equation so that B is going to come out. If you expand this and you try and find an expression that relates Sn to S sub m, it's just not going to be possible to do so without having B there, and so that is a reflection of the income effects. Now, there is a paper by Kongsamut, Rebello, and Xie, I think it's 2000, where what they do is they show that in general you're not going to get a balanced growth path with this kind of utility function. You can if there are certain coincidences among the parameters, but in general those coincidences are conditions that relate preference parameters to technology parameters, and so if your model depends on a knife edge condition like that, that's probably a concern. Later on, Timo Boppard showed that maybe this whole idea of using familiar utility functions is a mistake if we're trying to have both income effects on food, or maybe goods more generally, and a balanced growth path. Why don't we just write down the indirect utility function that has the ability to handle these two phenomena, and then prove that there exists a utility function that has this indirect utility function once you solve it all out, even if you can't write out that utility function analytically. And then more recently, Komin, Lashkari, and Mestieri have a different extension of the preference framework. Here, if you look at it, imagine that Cn gets really large. The income effects are going to disappear. The influence of this will become infinitesimally small. So they set up a different utility function that has non-vanishing income effects. In other words, no matter how big the economy gets, people will still be experiencing income effects, and those income effects will continue to affect spending patterns. And the neat thing about that model is that it shows that deep down there's no such thing as an income elasticity parameter. Income elasticities are only relative things. And so they can be determined only by parameters that govern relative income elasticity. I hope you find this useful in your research. There are plenty of other patterns of structural change out there for you to discover.